In our previous video, we talked about the atomic theory. So with what Dalton did, we now know about atom, and then in the chemistry scientific world, they came up with the word atom. So right now, we are ready to go into the atom and study more on the subatomic particles. And we are going to talk about the discovery of electrons in this video. So, as you know, as anyone at this time studying chemistry know that the atoms were discovered to not to be indivisible but to exist of subatomic particles. So everyone knows that atoms have electron, proton, and neutrons. But in this video, we are trying to um, see the story how these subatomic particles are discovered. So this is a discovery of electron. They discovered the scientist who did this was Thomson. He did the experiment, what is called cathode ray tube. This is a schematic of the experiment. So in this schematic, the first thing is there is an evacuated tube, and so in this evacuated tube they applied high voltage. So here they applied high voltage. So with this high voltage, we know they put a battery, and we know in the battery and the source is filled with electrons. We know it now, but at that time they didn't know this. So this battery was hooked up on a cathode and anode. So here is our cathode. What we cannot see in this picture is that the anode here has a hole inside, and what they see was that there was a beam passing through that hole and going to the tube and hitting the end of this tube. And they noticed that because they were coating the end of the tube with some chemicals that lit up when they were heated by the particle. So when they applied the high voltage, they saw that these particles were hitting the center of the tube. It was undeflected electron beam. So what they did, they started to do some experiments. So they applied magnetic and electric field and see what happens to the beam. So after I applied the field, they see that the beam was deflected. So they were hitting deflected from the original path. Okay. So what was interesting, so when they have this electric field from negative and positive, they saw that the beam in the electric field, they saw that the beam was deflected in a way that it was attracted to the positive side. Okay, it was attracted more on the positive side. So that tells us that this beam was from the particle which was negatively charged because it was absorbed to the positive side of the field. So to summarize the experiment, first, they had an evacuated tube. Second, they had high voltage, and they made a beam which was called, so it was, let's say 3, it was a beam which was called cathode ray. Cathode ray that was produced, and 4, they applied the electric and magnetic field and saw that this was deflected. So what did we get from this experiment? So this experiment showed us that there exist particles because there was something hitting on the tube, and we saw that because of the end of the tube lit up. So we know that there was some particles. Also, these particles are negatively charged. Why? Because they were repelled by the negative plate and it was attracted toward the positive plate. So that shows that these particles are negatively charged. Thomson did some work And with his work, he could determine the charge to mass ratio. Okay, and he know that the charge to mass ratio is this number here. He he couldn't find out what is the exact mass and what is the exact charge, but he knew that if he had a whole gram of the particle, the total charge was this number. So he knew the charge to mass, and this C is Coulomb. That's the unit for the charge. That's how we measure charge. So he knew that for a gram of the particle, he had this number Coulomb of charge. The other thing that he figured out with his experiment was that the mass of these particles was very, very light, and that was like 2,000 times lighter than the smallest particle, the smallest element, which was hydrogen, as the smallest element known. So Thomson did the experiment and find out the charge to mass ratio. So this is where Millikan's oil drop experiment comes in. So what he did, he designed this instrument that you can see in the figure. So basically it has two plates that are oppositely charged. Spraying the oil drops here and with the X-ray, it just adds some extra charge to it. There was a tiny hole here that led as you can see, these drop off the oil were coming down, and they had negative charges. So with changing the field, the negative field on the plate here, he could slow down or stop these particles here as with the viewing microscope. You can study more about these experiments by referring back to your book chapter 2.3, the history of atom. But basically that's what he did. So he was trying to find the mass, or let's say the charge of these electrons or negatively charged particles. So with his experiment, he could determine the charge of an electron. What he saw was that the charge, with playing with the field of course, the charge of these particles are multiples of a number, which was this number. It was either this or this number times 2. It was 3.2 or 4.8, and it was multiples of this number. So he understood that this number is a charge of one electron, and since in each droplet there might be different numbers of electron, he got multiples of that number. So with Millikan's oil drop experiment, they figured out the charge of one electron, and using what Thomson did, and with Thomson's work, we had the charge to mass ratio, and now we know the charge of one electron, so they could come up with a mass of one single electron. And as you can see, these are very, very small numbers. So what you need to know is you do not need to memorize these numbers. You just have to know the concept and where these numbers come from and how they discovered these numbers. So with Thomson's and Millikan's work, they discovered that there is a negatively charged particle, which is some part of atom that Dalton came up with the idea. So the question is, if atoms are neutral, and they know it was neutral, and it was neutral, if atoms are neutral and electrons are negatively charged, and that's part of the element, what else must be in an atom? What conclusion we can take? So think about these four options and choose one. So if you choose 2, that is right. So with a scientific logic, we can come up with this result that if atoms are neutral and if electrons is part of the atom and they are negatively charged, there should be something positive inside the atom. which now that we know it, it's proton. So in the next video, we are going to talk more about proton and how they discovered it.